Hello everyone, this is Dennis, and you are on the Den Electro channel. Today we will build an unusual device that allows you to regulate the power of appliances, change the brightness of a lamp, reduce the speed of electric motors, and control the temperature of electric heaters. All of this is possible because the circuit operates on the principle of pulse width modulation. Direct current is supplied to the input of this device, and the output will be pulsating. By turning the variable resistor, you can adjust the pulse width. Now let's see how our device works. Here I powered it from this device. This is a buck boost DC-DC converter. A review video of it is available on my channel, and the link will be in the description. Now I will supply a voltage of 12 volts from it to the input of our speed controller. I press the encoder. The voltage is displayed here, and below is the current consumption. At this time, the fan twitched slightly. Let's try again. I'll turn off the power and turn it back on. Right now, the pulses from our device are very short, so they need to be increased for the fan to start. I turn the knob and increase the pulse width. I'll set the speed to maximum. As you can see, everything works great. The speed increases and decreases. However, when the fan speed is at a medium level, it emits a barely audible high-pitched squeak. This happens because the current is not constant, but pulsating at a high frequency. Now let's try connecting something more powerful. For example, this halogen lamp. I press the encoder and supply power. The PWM controller is currently set to minimum, but a small current still goes to the lamp. The filament is glowing. I turn the regulator to increase the pulse length. As you can see, the lamp starts glowing brighter, and the current consumption increases. Now it's at maximum power, with a current of 3 amperes. The transistor doesn't heat up much. Right now, our PWM controller consumes 35 watts. But such power is quite acceptable for this circuit. The schematic of our PWM controller looks like this. It is built on the NE555 chip. Here I drew that the circuit is powered by 12 volts. But in fact, the voltage can be varied roughly from 10 to 24 volts. It all depends on the load voltage. The variable resistor used to change the pulse length is located right here. This is R2 at 47 kiloohms. The load connects right here. In the diagram, I showed an electric motor, but in reality, the load can be anything: a motor, a lamp, or a nichrome coil. You can also connect LEDs. All the load current passes through this field effect transistor Q1. I used an IRF 3205 here, but you can use another transistor as well. This circuit can also regulate loads with a current of 10 amperes, but you need to keep an eye on the transistor's temperature. If it heats up, a heatsink will be required. That's all for today. Leave a like, subscribe to the channel if you haven't already, ask your questions in the comments if anything is unclear, click the bell icon so you don't miss new videos, and bye everyone!